Hello students, today here in this video we are going to start chapter number 4, that is magnetic effect of current. So as we are starting about the magnetic effects, the very first topic or the concept that we should know is about the magnetic field. क्योंकि हम मैग्नेटिक इफेक्ट्स के बारे में पढ़ना स्टार्ट कर रहे हैं तो मैग्नेटिक फील्ड इज़ अ वेरी बेसिक थिंग जो हमें पता होना चाहिए, जिसका आइडिया होना चाहिए हमें दैट व्हाट वी आर डीलिंग विथ, हम क्या पढ़ने वाले हैं और हम किस बारे में बात कर रहे हैं. So to understand about magnetic field, I want to recall two previous topics that we have studied already. First is gravitation field. This we have studied in class 11th, and the second one is electric field. So in gravitation field we have studied that there is an object with mass capital M, और let it be earth, हम कोई भी ऑब्जेक्ट या इसको अर्थ कंसिडर कर सकते हैं with mass capital M, and if there is some another object smaller one with mass small m, then within a certain region, if it is placed in a certain region around this object of mass capital M, then it get influenced by some attractive force because of this mass capital M. मीन्स अगर ये स्मॉल एम मास कैपिटल एम मास की विसिनिटी में और इसके आसपास के किसी रीजन में, एक पर्टिकुलर रीजन में प्लेस्ड है, देन देयर एग्जिस्ट एन अट्रैक्टिव फोर्स टूवर्ड्स द सेंटर ऑफ द earth or towards the center of the mass capital M, then this phenomena or this force only exerts if this mass small m is placed in the vicinity of mass capital M. then this region जिसमें ये वाला फोर्स आपको कैपिटल एफ मिलेगा, आप ऑब्जर्व करोगे या ये फोर्स एग्जर्ट करेगा मास एम पर, दिस मच रीजन अराउंड द मास कैपिटल एम इज कॉल्ड ग्रेविटेशन फील्ड. Or the region around the mass capital M within which this mass can exert an attractive force to some other mass is called gravitation field, and this gravitation field is because of the mass of these objects. So the reason for the gravitation field is the mass of these objects, right? This was about the gravitation field. Come to the electric field. Now just as gravitation field was because of the mass, electric field is because of the charge, or I should say stationary charge. Like if I have an stationary charge placed here Q, and there exists some test charge or some other charge, any charge Q dash near to this charge Q, then within a certain region the charge Q exerts some force on Q dash. Now this force can be attractive or repulsive depending on the nature of the charge Q and Q dash. If these are similar or like charges, then they get repelled. If these are opposite charges, then they get attracted. But whole this process only occur if this charge Q dash is placed near to the charge Q, or there exists a region. अगर इस रीजन में ये Q डैश प्लेस्ड होगा, then only Q is capable of exerting some force on Q dash. Means there is a region around the charge Q within which if we place another charge Q dash, then Q dash experience some force, either attractive or repulsive, because of the charge Q. Then this region, जिस region में ये force possible होगा, this region is called electric field, and this electric field exerts because of the charge. Just as the region around the mass is called gravitation field, and this is because of the mass, similarly around the charge the region is called electric field, and the reason for this is the charge. Now come to the point magnetic field. Magnetic field में क्या होगा? Let us consider that we have a magnet. Now I am not going into the history of the magnet, I am just considering that I have a magnet placed here and a piece of iron like this. All right, so we know that the nature of magnet is to attract the piece of iron. This is magnet and this is a piece of iron. Then iron get attracted towards the magnet. But if we place this iron piece far away from the magnet, like here, if I put this iron piece far away from the magnet, then we observe that there is no force exerting on the piece of iron, or there is no attraction. So we conclude that around the magnet, this piece के ये वाला जो piece होगा near by जो place होगा, it will get attracted towards the magnet. But if we place it like here, then it won't be attracted. So what we conclude that कि magnet के around there exists some region. अगर आयरन का पीस इस रीजन के अंदर है, ओनली देन इट कैन बी अट्रैक्टेड बाय द मैग्नेट, अदरवाइज magnet won't exert any force on the piece of iron. Means around the magnet there exists some region inside which it can show magnetic forces, or we can say there exists a space around the magnet within which it can influence a force, राइट मीन्स अगर आप वहाँ पे आयरन का या किसी और मैग्नेटिक मटेरियल का पीस रखते हो, देन दैट पीस कैन इन्फ्लुएंस अ फोर्स इन दैट स्पेस, देन दैट स्पेस इज कॉल्ड मैग्नेटिक फील्ड. सो दिस स्पेस अराउंड द magnet within which it influence the attractive force, that space around the magnet is called magnetic field. What we can write, the space around a magnet within which it can, or within which its influence can be experienced is called its magnetic field. वो रीजन जहाँ तक हमें मैग्नेट का इन्फ्लुएंस मिलेगा या मैग्नेटिक की वजह से फोर्स एक्सपीरियंस कर पाएगा मैग्नेटिक मटेरियल, दैट रीजन अराउंड द मैग्नेट इज कॉल्ड मैग्नेटिक फील्ड. Now this was the basic idea of the magnetic field. Means अगर आपके पास mass है, then you will see some gravitation field. If you have some charge stationary, then you can observe an electric field. And if we have a magnet, then we can observe a magnetic field. Magnet है तो magnetic field होगा. This is natural. But there comes a revolutionary change in this whole idea when Oersted performed an experiment and proved that without magnet we can even produce a magnetic field. So Oersted ने अपने experiment में क्या prove किया, that without using a magnet, magnetic field can be produced. Let's see क्या किया उन्होंने experiment में. So Oersted in his experiment has a magnetic needle SN clamped over a stand. He also has a wire AB which is placed parallel to this needle and connected to a cell, as well as a plug key. Now we can show it by using a diagram also. So he connected a wire AB to a cell through a key and placed that wire parallel to the needle such that the current flows in the circuit from south to north, like this. So we connected the cell like this, so current will flow from south to north, and this wire AB is placed parallel to the needle. So what he observed, that when current flows from south to north, the north pole of the needle, of this magnetic needle, gets deflected towards the west. Now let's see the directions. Directions कैसे होंगे? If this is north, this is south, then here is the west and this will be east. So उन्होंने क्या observe किया, that अगर आपका current flow हो रहा है circuit में या wire AB में from south to north, then this needle get deflected towards the west, means like this along this axis. So this is the new position of the needle. This needle get deflected towards the west, right? This much is the deflection. This is because of the current flowing in the direction south to north, right? Now in the second case, he reversed the direction of the current. What he did, this time he flows the current from north to south like this, means I am going to reverse the cells. सो टर्मिनल हमने चेंज कर दिया है सेल के, तो अब की बार जो करंट फ्लो होगा ए बी में, it will move from north to south like this. The wire AB is placed parallel to the needle. वायर AB को हमने needle के parallel place किया है. This is the north, this is south, and this time current is flowing from north to south. So he observed that when current flows from north to south, the north pole of magnetic needle get deflected towards the east, means this time deflection will happen towards the east. So the direction of needle will be like this, और the new position जो होगा needle का वो इस तरीके से मिलेगा हमें. दिस विल बी द नॉर्थ पोल and the needle get deflected towards the east, right? Again, the next thing that he found is if we place the wire below the needle, means हम upside parallel की जगह below parallel अगर हम रखते हैं, then these results get reversed. What he found was, अगर आप जो वायर आपने प्लेस किया है उसको बिलो कर देते हो निडल के, एंड देन यू विल सी द रिजल्ट, तो आपको डिफ्लेक्शन रिवर्स्ड मिलेगा. मीन्स जहाँ वेस्ट मिल रहा था, नाउ देयर यू विल बी गेटिंग ईस्ट, एंड जहाँ आपको ईस्ट मिल रहा था वहाँ आपको वेस्ट मिलेगा. नेक्स्ट थिंग दैट ही ऑब्जर्व्ड वाज, इफ़ वी stop the flow of current across the wire, then in that case needle came back to its initial position, or there will be no deflection when we stop the flow of current. means जैसे ही current को stop करेंगे circuit में, needle वापस अपने initial position पे आ जाएगा and there will be no deflection in the needle. that shows that कि जो आपका deflection था वो करंट के फ्लो की वजह से था. बट अकॉर्डिंग टू द नेचर ऑफ मैग्नेटिक निडल, इट कैन बी डिफ्लेक्टेड ओनली बाय द प्रेजेंस ऑफ अ मैग्नेटिक फील्ड. तो मैग्नेटिक निडल मैग्नेटिक फील्ड की वजह से डिफ्लेक्ट हो सकता था, बट हेयर इट वॉज डिफ्लेक्टेड because of the flow of current. So he connected the results and found that actually the flow of current is producing a magnetic field around the conductor, जिसकी वजह से वो मैग्नेटिक निडल डिफ्लेक्ट हो रहा है. मीन्स उन्होंने रिजल्ट्स को कनेक्ट किया और कंक्लूड किया कि ये जो करंट फ्लो हो रहा है, इसी करंट की वजह से इस कंडक्टर ए बी के अक्रॉस एक मैग्नेटिक फील्ड प्रोड्यूस हो रहा है, और क्योंकि वो निडल उस मैग्नेटिक फील्ड के रीजन के अंदर आ रहा है, दैट्स वाई इट इज़ डिफ्लेक्टेड. it gets deflected because of that magnetic field created by the flow of current. अगर ये current नहीं होगा, then there will be no magnetic field, and that magnetic needle will show no deflection. So the experiment of Oersted results that a current carrying conductor produces a magnetic field around it. This is the main result of Oersted experiment, and because of this idea, this whole chapter is going to revolve around this idea only. Means in this chapter we are going to study the phenomena जिनमें करंट के फ्लो की वजह से मैग्नेटिक फील्ड प्रोड्यूस हो रहा है, एंड वी विल बी स्टडिंग दैट कि कैसे क्या फिनोमिना हुआ और हमें क्या रिजल्ट्स मिल रहे हैं. सो the whole concept of magnetic effect of current revolves around this result of Oersted experiment कि जो आपके currents हैं उनकी वजह से हमें magnetic effect मिलता है, magnetic field produce होता है, that we are going to study in the coming videos, right? So this was all about the introduction of this chapter, magnetic effect of current. कि idea कहाँ से आया हमें कि करंट की वजह से कुछ मैग्नेटिक इफेक्ट्स या फिनोमेना हो रहे हैं दैट वी आर गोइंग टू स्टडी. सो इट वाज ऑल बिकॉज ऑफ द ऑस्टेड एक्सपेरिमेंट. सो वी विल बी स्टडिंग next coming topics in this chapter in the coming videos. Till then, stay tuned, stay safe and keep studying. Thank you.